Anyone of you have any doubt in the derivation part? These derivations you have to practice a lot, because if you want to understand the derivation process, uh, when we are doing it first time, we already did it 2 or 3 times in masters, and then after that, I think I did it more than 10 and 12 times. So these derivations, there are so many tricky steps here. Means that logic behind those steps you have to find, and the more you practice and more you read about those derivation parts and the logic behind that, then maximum you can learn about those derivations. Okay, so there is no doubt. Then let me start with the next part, that's the assumptions of the OLS method. So first, just try to understand this process. Is Anshul joined today? No. Okay. Okay. So maximum participant, I think, not attending class in this particular week. This was the crucial week. This derivation part. So later on, they might find difficulty. Then I request to others you can help them. Otherwise, it's upon them that how they do practice or not. Okay. So let's come to the first basic again. Initial, we have some theory, and to find numerical estimates, we converted that theory into a mathematical model. In the mathematical model, there are few important things that I already explained to you. That in mathematical model, you have to clearly define first what variables you are taking, which one is your dependent variable, which one is your independent variable. When you have a variables in your theory, that variables you have to define. Then you convert it into a mathematical model, your theory. That's the first step. And within that, there are a few 3 or 4 important things that in the first class I already explained you. That first, in the mathematical model, actually this model is in the form of relations and functions. In functions, you define that any particular variable depend upon other variables. That's your dependent variable, and others are your independent variable. In that particular variable, you define that is that relation is linear, non-linear, means function you have to decide about those independent variables. Sign relation, that is it negatively related or positively. These all things you have to define from the theory, means that we did in the very beginning of this particular econometrics part. That in the first step you have is to define the mathematical model, that how you identify the model. And these 4 steps you have to take care when you make a mathematical model. Which one is a dependent, independent variable? Then specific functional form, is those variable you have in the research are linearly related or non-linear? That functional form you have to decide. Then sign of the coefficient, is it positively related or negatively related? And then is it a single equation model or multiple equation model? And when you clear with your mathematical model that okay, this is my mathematical model, then we have to convert it into a econometric model. And econometric model, we give a space to the unknown factors with the residual term. Now in initial last 2 classes, we did estimate of sample estimate of econometric model. In bivariate case, means this derivation we have done with the OLS method, and in multivariate we did this with the matrix method, because now we have a econometric model. So the next step is, after econometric model, your step is to measure the estimates, and to measure the estimates some method is required, for example OLS or MLE method. But how can we rely on this particular method? Is it appropriate to find these estimates? So there are few properties proved for this particular method, And with that particular properties, we can decide whether this method is appropriate for this particular derivation of estimates or not. But those properties will only fulfill or possible if the assumptions of this particular method will be fulfilled. It's like you are going to buy a mobile phone and you want specific features. So that specific feature is only possible if you pay for that. If these assumptions will fulfill, then only the specific properties on the basis you have deciding that this OLS is useful for to estimate these derivations, that only possible if assumptions will fulfill. So this is the process that how we study these models and the estimate methods. So far, we only did the estimate, right? Means the extraction of this derivation of this bivariate model and multivariate model to how we find the estimates, this beta, the coefficients of your independent variable. And this you are why you are deriving this, because in your econometric model you have these estimates, and the whole purpose of your exercise of econometric thing is to find the estimates of these coefficients so that you can make some policy forecasting or whatever the research question, the purpose you have, that what type of relation you want to find and why you want to find these coefficients, that and this is generally the impact. These coefficients will tell us the impact of one variable on the another variable. So that's in the behind that you have some theory, and for that theory you have converted into a mathematical model, and from mathematical model now we have a space for unknown factors, because this is social science and human decisions. It's not possible you can capture all the human decisions. So some space is required for unknown factors, and that space we give with the residual term in econometric model, these residual terms. And to the estimate, we are using one specific OLS method. Means the derivation, these we did with the OLS method, and there is a specific purpose behind that. These OLS estimates have the specific properties, and that's very useful, so that we can rely on these estimates. But these properties, we will do maybe one or two today, and maybe tomorrow or day after tomorrow. But these will be only possible when the assumptions of this model will be fulfilled. For example, demand and supply, or the law of demand, that's only possible if you hold other things constant, and there are so many other assumptions like in that particular law of demand. Similarly, we have few properties about these estimates based upon this method, but that's only possible if assumptions will fulfill. So today we are going to discuss first assumptions, because with the estimation part we already done with the bivariate model and the multivariate model. Means if you have one independent variable or if you have more than one independent variable, the matrix method we have done. So today I'm going to start with the assumptions. So this thing you have to keep in mind, that what actually you are doing in econometrics. This background you always have to keep in your mind. Whenever you're doing any derivation or somewhere, you have to link that particular step in the process, that actually where you are, means in which process you are. These days, these coefficients will be possible with the software, means you are not required to do anything. So if you have a data, softwares will give you these estimates, but at least you have to specify the model to the software, that what is your model, what is your econometric model. And second, so the software you have to provide these instructions that uh, generally these softwares have with the OLS methods and these econometric coefficients. But with that, after the results, the interpretation part is yours. The software is going to give you the table, but interpretation, the conclusions, what are the implications, that you have to find. Means that depends upon, and to understand that, you have to understand this whole process. But this estimates is not only the thing that we are going to derive. With that, two other things are also important, like variance of these estimates. Means if the variance is high, then it's not appropriate to use these estimates. Then goodness of fit, means how well is your overall model, or how much is the variation in dependent variable is explained by the independent variables. So there are few other things that we are also required with this model. And in the end, after all the estimates of goodness of fit, variance, estimates, the last, as we are doing from the very beginning of the descriptive stats, hypothesis testing is required. That is, these coefficients which you have estimates with the bivariate or matrix method, are they statistically significant? For that, we need a hypothesis testing. And for the overall significance of the model, again, we need a hypothesis testing. So with these estimates, we also need variance of these estimates, then goodness of fit, and hypothesis testing for individual significance of these variables and overall significance of the model. So whenever you apply any regression model, the table, this, for example, let's see the last table. Yeah, these tables, this give you all these figures. All these figures they will give you estimates. These are the estimates: beta 1, beta 2, beta 3, beta 4. It's standard error that's come from the variance and the root of the variance. With that goodness of it, R square, here you will find it. T-stat values to check hypothesis testing of these individual coefficients. Three approaches you can apply: p-value, test of significance approach, or confidence interval, whichever approach you want to apply. All these four figures are about hypothesis testing of individual significance, statistical significance of the independent variables. With that, we also need overall significance of the model that we did in the part 2 with the F test, if you remember that. And for F test, we need all these other values, mean sum of squares of the model and residuals. That's about the F ratio, F stat value. And with that, we have to decide whether overall model is significant or not. So all these values we have to estimate for the regression model. But these values will depend upon the nature of the model. Like, for example, in this particular part 3, as I told you that we are restricted to the one combination, cross section, quantitative dependent variable, and quantitative and nominal scale independent variables. So that's one combination. But if this combination will change, like we have a time series or we have a qualitative dependent variable, then we need some modifications in this model or methods. So again, this exercise will remain same. Means we have to again calculate all these values, all these stable values. But now then the process will change. There might be, in place of OLS, we apply MLE. If it's a qualitative dependent variable, then we have to understand the process of MLE. Is it there any properties with the MLE? Is there any assumptions with the MLE? How we estimate the coefficients of independent variables with the MLE? Then the whole process will change. I mean, this depends upon your econometric model, the type of data you have. Is it cross-section or is it a time series data? Is it your dependent variable is quantitative or qualitative? Then the whole process will change. So then again, you have to understand that process. That's why we divide econometrics into three parts. That first, generally we did with the cross-sectional data, then time series, and then for qualitative dependent variables, we have this logic Tobit and Tobit model. So that's a division in the econometrics, and that's we have to understand whole process. Means the very beginning, this particular thing, the model you have, variables in the model, nature of those variables, that will decide all these things. So this aggregate picture you have to keep in mind. And right now we started with the estimate part. We did the estimate with the bivariate. So any one of you joining first time, then initial three videos of this particular series that you have to watch from the very beginning, methodology of econometrics, and then how we estimate these parameters with the OLS specific technique. It's not the OLS technique you have to always go into. It might be MLE. That depends upon the combination of your type of variable you have, nature of variables you have, type of data you have, the methods will depend upon. So these things you have to segregate. Means I don't studying this means only the lecture you are attending or you are doing it practice, that I really don't have any idea means how much time you're spending. The more time you spend, the more clarity you have. And with these lectures, at least you have to go with the reading with the Gujarati textbook or Chinese or Madala or Woolrich, I mean any of these standard textbooks, that at least you have to understand this theoretical background about all these steps. So far, we only done with the estimate, and this part 3 is restricted to cross-sectional data and quantitative dependent variables. So that's why we are going with the OLS method. So we applied OLS, and with the OLS we estimated in the bivariate derivation and for the with the matrix method. So next is it this OLS estimates, the estimates which we found are reliable? Means like for example, these are the estimates. Means is there something properties, means how we can rely this OLS estimate? So there are some properties. So I'll come to properties later on. Before that, you have to understand the assumptions first, because these properties will only fulfill when these assumptions will met. So the next step, and after that, means after these assumptions and properties, then we have to also calculate this goodness of fit, variance of these estimates, and then after that, next week I will start hypothesis testing part for this regression model, for the multivariate regression model. So this is we have done so far in this estimate part. So this estimate is done. But with this estimate, then we have to find that whether the estimates are appropriate or not. So to understand these properties, first go with the assumptions. Today, first I'll start with the OLS assumptions. And for OLS assumptions, I'm going to start it with the Gujarati assumptions. These assumptions are in all the econometric textbooks. You can read from any of the textbooks you want. I'm taking reference from the Gujarati textbook. Before that, any doubts so far in these steps, that what we are doing actually? The maximum time, the problem with the econometrics is that we lost it somewhere in the derivations, that actually what we have started, why we have started, how we are doing, and when we have to do that thing. So many times I found that we lost somewhere in the derivations and mathematical equations, the whole background, what we are actually doing. That connection we miss, and we can't understand that what actually we are doing. So that connection you have always keep in mind, that whatever step you are doing, why you are doing that step, when that step is required, and how you have to do that. So any doubt in this particular? If the second thing, the 90%, I found that students doubts are only when they are not doing the homework. It's not that always they're doing the homework, but the consistency that required and the efforts in these derivations. Means in these derivations, I try to make it as simple as possible. Means, but still, if you have any doubt in any part, then you can ask in the class. In the next class that I was trying this particular derivation, but I stuck here. But if you are not doing it right now, and you might be thinking that I'll do it after 1 month or 2 months, and then you will put in the query. So that's not appropriate. Means in the part 4, then you will ask me a query of this particular step. Or when we will done with these all derivations, and after that, if you ask that I'm stuck here, so that's not appropriate. So in the very beginning, in the first class, in the part 1, I already told you that homework is your duty, means that you have to do. If you are not doing, then I can't help you. It's not possible for me. So that's upon you. Means I don't know now. I have no idea that whether you all understood these derivations or you have not even tried these derivations. That I really don't have any idea. Okay, I am keeping this assumption, like the OLS assumption, that you are doing with the classes and you are practicing, and you are getting these understanding of these steps, that why these steps, where these steps are important, what is the sequence of this step, where we are in between. Means with your research question, when you start your PhDs or research papers, the end part is your results of the econometric models if you are applying. That's not necessary that you always apply the econometric models. That's not necessary at all. But if you are applying, then in the end you have the results, and then you try to analyze those results and then implications about those results. So from beginning to end, there are so many n number of steps. Similarly, in econometrics, from estimate to last hypothesis testing, there are so many steps in between, and we have to make those connections that what we are doing. Okay, so let's start with the OLS assumptions. Now, first, what these assumptions are and about what these assumptions are. We are trying to estimate the estimates of this regression model, the econometric model. So these assumptions are related to this econometric model. In this econometric model, we have three different things. Or I can say four different things. First, you have independent variables, dependent variables, and residual term. So few of the assumptions are related to behavior of these variables: dependent, independent, and residual term. Two or three or four assumptions are just restricted to residual term. Second, few of the assumptions are about your model as well, that how well is your model is specified. That's also important when we try to estimate. So this OLS model has assumptions about the nature of these variables, the relation of these variables with each other, or with the residual term, or the residual term with the dependent variable. So these assumptions are about your model and the behavior of your variables. Means whatever things you have in the model, these assumptions are only restricted to those parts. So first, just try to understand these assumptions. So these are the requirements. If you are applying OLS method to any econometric model or regression model, first you have to cross-check these assumptions. Are these assumptions are fulfilled or not? If they are not fulfilling, is there might be some problem with any assumption? Then first you have to try to find some solution about that problem. And if you are not able to find the solution, then the ways that you have to left means then you can't apply this OLS method. So that you have to keep in mind. So it's not possible that always you can apply the OLS model. There are a few assumptions, and these assumptions you have to keep in mind. Like law of demand, that's only I never seen this law of demand with the numerical measurement in the real phenomena, because those assumptions are not possible at all. That you can keep constant income of the individuals, or you can keep price of the substitute goods. There are so many assumptions, and that's not possible all the way. So practically that's not possible, but in reality, theoretically, that's possible. So this is some change in the econometric methods, and empirical estimates nowadays. It's important that if you are taking some notion in theory about something, then you have to give numerical estimates as well. So first assumption is the regression model is linear in parameters. Now here, this assumption is about your beta coefficients. Now don't get confused that why not hat here, or why not is this a population regression function or sample regression function? That change in the notations, that's only to estimate and give this notion that we are estimating with the sample data, because we generally work with the sample data. So don't get confused with that in the assumptions. Soumya, how can you say that? Means you now take example of law of demand. Do you think that those assumptions are not possible, or this is the something about the economic models? If I go to the models, when you have to something in the model to keep a model as simple as possible, definitely you have to keep other things constant. I mean, it's something like we do in mathematics and physics experiments, then we control everything, but in social science it's not possible. So economists in economic models, they try to control few things, then only it's possible. Means let's suppose you have any variable that depend upon any other n number of variables. So, and at any particular stage, if you want to try the relationship between only those two variables, then you have to keep control other variables. Means other variables are constant at that moment. If you can't keep them constant, then it's not possible you can find any relationship between any of the variables. So that then theoretical meaning is that why we study theories means possible at all, means all the theories we have to reject because there is no theory without assumption in social sciences. So that's the practical thing is, and if it's not about the model, then it's about the theory that we formulate the theories if they are not proved true. So that's the limitation of the models we always have, assumptions we have to take. No, no, it's not subjective thing. I don't want to go that. Means some theories have more practical, some theories. That's our notion might be somewhere. Let me tell you. Our knowledge is very limited. Like, for example, let's suppose I will say that I think that classical assumptions are not possible to fulfill. So it might be that whether I'm aware of all the classical literature, means do we have I have studied Ricardo, Karl Marx, Adam Smith, all the theoretical explanations, and then I have reached to this conclusion, or it is just that I have studied few textbooks and few theories from the just in my courses, and then I have to reach to this conclusion. Means theoretically, I am speaking to reject any theory or proof. This is some research that we have to go through all the literature. Then only we can judge these theories. But it's something that our limited to our knowledge is that we think that this theory is applicable, this is not applicable. But in general, the maximum theories we study in master and graduate courses are those which are proved to be right in maximum at maximum possible places, spaces, or the times. Is that space you have to geographic as well as the time that we generally study, but that's the limitation of our knowledge, the time we have spent upon the literature. So it's not that some have limited practicability, some have maximum. Is that depend upon the specific research question? But the thing is, there is no model without assumptions in social sciences. Yes, if you want to see relationship between any two variable of the social science, you definitely have to keep other things constant. Otherwise, it's not possible to measure those relations. Is it micro, macro, any economic or non-economic variables in the social science? Similarly, in these econometric models, if let's suppose these assumptions, we don't have these assumptions. The second thing is then might be it's not possible to estimate these parameters. Or it might be possible to estimate the parameters. It's not possible to find whether they are useful or not. Are they appropriate or no? And since, as I told you, that in econometric models, we give a space to the unknown factors. So definitely now we have to go with the assumptions that how we try to make these estimates meaningful. So for that, we have to keep some assumptions, and that assumptions, this OLS model we have. That thing is your choice. Is you are a researcher. This is your choice that after studying this particular model or method, you want to apply or not. Means here the judgment is yours, the call is yours. If you think that these assumptions are impractical and not possible, then you can't apply this model. And if you think it's possible, you can apply. So there is no yes and no question. Means there are many economists who don't apply OLS models because they think these assumptions are not possible to fulfill all the time. And there are economists who prefer to apply OLS, means if they have some problems in the data or at some particular assumption, they try to find the solutions. So both the economists and both the type of researchers we have. So this call is yours in the end. So means it's up to you. You are learning any specific method. In the end, this call you have to take whether you are going to apply this model or not. So that choice is totally yours. Means that judgment you have to take in the end. There is no and the criteria for judgment is the these assumptions. If you see that these assumptions are fulfilling in your particular research question or econometric model, I suggest you can go with the OLS model or MLE model, whichever you are applying. And if you think it's and uses a crucial assumption is not possible to fulfill with your data, so then you have to skip the. But the theory is reverse, means in the practically earlier also I'm telling you that what researchers will do, they collect data and variable in such a manner, they take a research such person in such a manner that they are going to apply the OLS. Means they don't have this thing in the mind that we have this theory and then they start to see whether this model is applicable or not. But a maximum such what they are doing that they think that okay, OLS is need to apply, so they are changing their variables, data, and nature of variables, that data mining and manipulations they are doing. But that's not the appropriate way in the research. It might be that it's not possible to apply OLS. So you have to just you need to find some another solution to prove your empirical estimates. That's your innovation and your research. That homework you have to do in research. Okay, so let's suppose in econometric course, the first assumption is that let's suppose you are going to apply the OLS, so or MLE method. So for that, you have to understand these methods. So first assumption is about the parameters. These parameters are your beta 1 and beta 2 or beta 3. So assumption is saying that it needs to be linear. Now, what it means then? The regression model is linear in parameters. This is the assumption. Now, what it means? Anyone of you? What it means? This type of question I also found in UGC net exams and all. Uh, Many times they ask this type of questions as well. So, any one of you, what it means that regression model is linear in parameters? Parameters are here, beta 1, beta 2, or beta 3, beta 4, depends upon your econometric model. And the second is why we need it linear. First, they needs to be linear, that's the assumption, but why? Sorry, saying regression line is linear. No, sir. That's about the variables. It's not about the independent variable functional form that is x is required a linear or x square. No, it's not about that. It's about the parameters. Our line might be non-linear. That's not a harm in the regression model. Okay, so go to this derivation here. Let me go to the bivariate derivation. We tried to, the purpose is we need this regression line. And for this regression line, parameters are required, beta 1, beta 2, intercept and slope coefficient. If it's a bivariate, if it's a multivariate, then partial slope coefficients are required. So in the differentiation, if you see here that we try to differentiate this first regression equation, this econometric equation. Now, this is your assignment. You can try this. Take any non-parametric parameter here, like beta 1 square, and then just cross-check. Is it possible that if we have this non-parameter, then we can differentiate and find the value of parameters? Non-linear parameter mean slope changes which make our regression line non-linear. But for that we have a district that mathematical model we can take non-linear mathematical model, means not only the parameter but in place of parameter you can take any of the non-linear functional mathematical model. So means for non-linear we have other models. It's not necessary. Yes, that's true. We have two options. Either you can pick any parameter that which is appropriate for the non-linear function, but the vice versa trick we play for the non-linear cases that we go by other non-linear functional forms. Let me go back to this. The other mathematical examples we are taking in this classes. Yeah, these one. And if let's suppose you want this non-linear regression line, so that's also possible with the you can add other appropriate variables in model. Like if you need some quadratic, then go with the second degree polynomial model. Or if you have this type of curve, go with the dependent. In these changes you can do with your variables in place of parameter. But the common thing here is you can see here A, B, C, D, or A or B. These are linear. Although this regression line is not linear at all. Means to estimate this regression line, non-linear regression line, we can go with this mathematical functional form. It's not the regression line is linear, but our parameters needs to be linear. And it's not that if parameters are linear, then regression line is straight line. No, that's not the case here. We have a non-linear regression models like Philip curve and all that we can apply in econometric as well. But the only requirement for the OLS method is that parameters needs to be linear, and it has nothing to do with the linear regression line. That OLS has this assumption because in OLS we have to estimate the linear regression line. No, it has nothing to do with that thing because in with OLS you can also estimate these type of non-linear regression lines. Then you have to modify your models. Means that's what I'm saying. Before the econometric model, the step is mathematical model, that which mathematical model you are applying. But the restriction is you have to keep parameters in the linear form. Means under root, square, cube, no any other form, just a simple linear form you have to keep. So why we have this assumption? It's not that just because we need a regression line, straight line, that's why this assumption is no. It's nothing to do with that particular straight regression line. That's not about this particular assumption. Means in OLS, it's not a restriction that we can only estimate a uh, straight line. No, you can estimate other non-straight lines as well. Curve, convex, concave. There are other curves, means mathematical forms. So why this assumption then? The trick is if I give you some simple solution to this answer, just this try non-linear, like take a under root of beta 1 here or beta 0 square, any other non-linear, and just try to solve this derivation. And you will find this answer that why in the OLS it needs to be linear, because if you go with any other form, you will face a difficulty in the derivation of this particular equation that where we are trying to minimize the summation you had square. Here you will find a difficulty, and this assumption is about this crucial problem. It's not about the straight line regression line, it's about this derivation. So take any non-linear form, this homework I'm giving you, that put here under root or square, whatever non-linear form you want, and then try to estimate the parameters, and then you will get this answer that these estimates then not possible if you go with the other non-linear form, and the problem you will face in the differentiation here itself. And that's the main thing here, that it's not possible that you can differentiate and you can find these estimates the way we are finding with the OLS method if they are non-linear. So this is nothing with the regression line or the straight line. It's about the derivation part. So you have to try with this. Just try, put any, take a square under root, and you will get this answer that why it needs to be a linear. Means otherwise, the estimate the formula you're getting, it's not possible. That's why the assumption is here. And this is the first assumption. Then you have to think about it. Why it's at the first place? Because at the first place, if we are not able to estimate this beta 1, beta 2, then there is no use of the OLS method at all. And that's only possible estimation if you have a linear parameters. If your parameters, there is no problem with the x that it's a square under root, means non-linear form. but with the parameters only. I hope you got this point that it is not about the regression line, but it's about the this derivation of estimate. This assumption is that's why it's crucial. Stop me anywhere you have this doubt or any counter argument because these econometric things, although I'm studying is 10th or 12th time, but always I found something new in it. Means many times I missed few points, and that explanations are important to understand in the theoretical background. This is something like a web series or thrilling movies you want, where they start with 5 or 4 different stories, and then in the end they connect. This econometric subject is something like that. Like we start with this 4 or 5 different stories means, and in the end we have to connect all this. So this skill is required here. Means something this puzzling games where you have or the chess if you play means this type of concentration is required in this particular subject that you have to study things in the parts and then in the end you have to connect all those puzzles. So right now we are in the assumption. So I hope this first assumption is now clear. Linear parameters and with that I try to give you answer that why it's important. Assumption I can explain, but why the assumptions that's more crucial part, and I'm still trying to find answers or why part because that's important here. Next, x values are fixed in repeated sampling. Now here you have something. X values are fixed in. Now, although in the starting I told you, now you have to keep this thing in mind. Like before assumption I told you, these assumptions are about your econometric models. Either these variables model, relation of these variables, type of these variables, or residual. So one or the other way, these assumptions are connected with these because the way estimation derivation we are doing and the properties which we are looking that on the basis we are going to adapt this OLS method is based upon the assumptions. And that's why this is a crucial term. The second is x values are fixed in repeated sampling. Now, you might think that we have only one sample, so but it's about the repeated sampling means why this assumption is. So far, in the derivation part, the derivation we have done so far to estimate the beta coefficients, these assumptions were not required. So you might be thinking that why this assumption and where we have to fit this assumption. But the properties that I was talking that the properties which are depend and which are actually the like features of mobile phone. Latest feature you can say that you can only buy a mobile phone if you have these features. But these features only possible with these assumptions. So this assumption is that if you have let's suppose 10 or 20 samples. So in those samples, at least your x is fixed. If I can give you these examples from the okay. Let me give you the example from the this textbook as well. They have this particular table in the chapter 2. Yeah, this example you will find in the textbook that if you have let's suppose 5, 6, 7, any type of samples. So generally what we are trying to here doing in this regression models, if you can see from the graphical images, we are trying to find the value of dependent variable, expected value of dependent variable given the x. So if it's more than one or other samples means, then at least you have to fix this value. Then only you can find the change in these y variables. I mean, let's suppose you can think that if x is changing, y is changing, then how you can estimate y based upon the x? At least you have to fix one parameter, right? So when we estimate this y hat values, we put x values in the equations and we will get these estimated y values. So it means our x is fixed in repeated samplings. But practically we only have a one sample. So if you are doing only a one sample thing, then this is not that if you have to means this experiment thing that take a 10 samples and fix that. It's not like that. It's this assumption is for some theoretical properties. So these things, it's not that practically you're going to do that you have a 15 samples and then you're keeping the X fixed. It's not like that. But for some theoretical properties, these type of natures and assumptions are crucial. But simply just try to understand that in all these graphical explanations, we are trying to see that given the X value, what is the expected value of Y? So it means we are trying to fix some X parameter, and on that particular X value, we are estimating or we're trying to look upon the behavior of Y. That okay, this is the X, another X value. Now where these Y values? So you have to keep at least one of the variable fixed to see the changes of other variables. So for simplicity, or for various theoretical proof, derivational proofs, this assumption is required in the OLS model. So it's deliberately this assumption is in this particular model that your X values are fixed in repeated sampling. Means so far I can understand we only have one sample, so it's not easy to understand that what is in the repeated sampling or why we are talking about the other samples. But as in the beginning, I told you that we started it with the residual U hat term. We are trying to minimize the residual term, although we don't know the residual term. This unknown factors value we don't have, and we are trying to minimize. So there are many things which are theoretically we are doing. Its implications are practical, but practically that's not possible at all. I hope you get this point. It's very crucial that you don't have unknown factor data, right? Residual. So practically, you don't know that how to minimize that unless you have data. But theoretically, we prove that you are minimizing the residual term, and that in the data, residual term is in the end. That first we estimated the parameters, then with the parameters we estimated the y values. Then we take a subtraction of actual y minus y hat, and that was the residual term. So in calculation, it is in the end. But in derivation, it's in the first place that we are trying to minimize the residual term. So this sequence and tricks you have to miss. This is something unique about this subject that, and all the other subjects, there is some way to read and understand the subject, and this is the requirement of econometrics. I hope you got this point that what this means that, but there are many implications of this particular assumption in the derivations in properties. And there I'll give you this explanation again that here this assumption is required. Means for theoretical proofs it is required. Then third, zero mean value of disturbance term. And this view I also given two examples in the very beginning that if you apply a OLS model and then if in the end you will find summation of u hat that's approximately nearby zero, and if you take its average when divided by n, then again it's going to be a zero. And indirectly what it means that values are generally equally distributed. Means few of the actual values of the regression line, sorry, this dependent variable are upside the regression line, and few are the downside the regression line. So if you take that average, that nearby zero. Now this is a technical that this sum is zero, but what it means in theoretical terms is that on an average the values of unknown factors is zero. It's the unknown factors which we have given a space in the econometric model, its average is zero. Means it's not that they are not impacting, they are impacting, but their impact is something like that few of the impact is just upside the regression line and few in the downside. This I'm talking in the technical terms. Theoretical meaning is totally different. And if that cancel it out, then average is nearby 0. So from the average, now we are taking it assumption that it means this distribution around the regression line is a normal type of like upside and downside. Then it's possible that its average will be 0. Now the question is why this assumption? If it's an assumption that we are taking this assumption, then why this assumption is required and why this is crucial? Nimisha is present. Divya is present. Any one of you want to answer this assumption? Or Pallavi? Pallavi throughout the series is adopted this silence space. I don't know why. But we have to contribute. We have to ask a question. Means I know you know these answers. You already have studied this. Many times I just ask these questions because maybe you give some explanation which I am missing. This econometrics update is something. The theoretical understanding is something like the maximum you learn and maximum you discuss, the better explanation you will get. It's not that one can teach you this econometric, theoretical econometric course. Practically applied part, one can teach with the software and interpretations part, but the theoretical explanation of these models, that's something can only done with the study and discuss with as maximum researchers or the peer groups. So by this assumption, sorry for this disturbance, it's outside the home. Maybe they want to participate, I don't know. Okay. Anyone of you, why this assumption that residual term means its average is equal to 0. The theoretical when I gave this explanation that 0 means that distribution is upside and downside, the equal type of distribution. Welcome and below on the question 9 are equal. Yeah, Divya, that's theoretical meaning means, but I'm asking why it's important and why it's assumption. Just that's the same thing you are saying, but why this assumption? But its implication means if it's not the way this assumption is, what will be the problem? Biased estimates, yeah, true. And what it means, Divya, and what that is that might be a biased estimates, but what that means? Because few of the participants are doing it first time, so we have to give them theoretical or the practical explanation as well, so that they can understand the uh, reason behind these assumptions. Okay, let me give you this example from the graph. If I have okay, this is the graph. Let's suppose I have, okay, this example we have taken for this wage as a dependent variable and education as independent variable. So if the other way is, if I'll give you this graphical explanation, that what will be its opposite, means that's the only way we can compare this, that why this assumption is crucial. Let's suppose we have a y. This is my x variable. Let's suppose this is the wages and this is education. So if let's suppose my scatter plot is something like this, that there might be a positive relation between education and wages on an average. And my regression line is somewhere here. And another regression line, let me give it a 1. Another regression line is here, 2. And we have another regression line somewhere here. So now you can see about these 3 regression lines. This second line, you can say it's just a graphical image, that expected value of ui, means the residual term, is nearby 0 given the xi, right? Given the xi, the expected value of u is equal to 0. Means now think, is it possible for first, second, or third? So graphically, you can see that it's not possible for first, not for the third as well, only for the second. But we are saying we have this assumption. So why this assumption? We are saying if u is not 0, then it will be on other side of the line. But there is still some important variable which is left that we have not controlled. So what is playing an important role in the determination of y? Yeah, Divya, that's true. But let me take a case where it's not a case of that. We have included some extra variable, or we have excluded some important variable. Means just think of like you know the variables, and you know why you have this independent variable and why dependent variable. So there is no question in your mind that whether some important variable is missing or not. Means let's suppose you are clear about this theoretical question. This is something, the problem is that you might have applied some method, like maybe some other method, and then like let's suppose this first line, your data is somewhere here, right? And you have a line somewhere here. That line is not representative of that data. Remember the last time we did this properties, as the regression line passed through the mean, is the average mean of the y variable and mean of the x variable, means the regression line passed through the averages. That's only possible if you have this this is a relation that only possible when you have this random term normally distributed around the regression line. Otherwise, the bias thing you are saying, yes, that was true. Means you have this, let's put the first regression line. But the biased estimate means that this is not representative of the true regression line or the data set. And we have a line, or let's suppose we have this line. Not at all this line is giving any information, any relationship by y and x based upon the data. So we can't rely on this line at all. So we need at least a line which distribute these residuals equally, means we need estimate in such a manner that that regression line at least give this picture that we can use for the implications and the policy purposes, but that's only possible when that regression line is representative of that data set that you have, the relation you have. It might be linear, non-linear, but at least that line is of that particular nature, means that describe that data. Now, if you have this particular line, like the first case, now maximum residual terms are in the downside, so summation is not zero, average is not zero. Again, in the third case, maximum residuals are in the upsides. Again, the average is not possible to zero. The distribution of residuals needs to be normal so that that line will be representative of the data. Yeah, simply, yeah, Harminder sir is right. Means regression line is not good fitted if u is not equal to, yeah, simply you can also say that. Yeah, that's why I'm saying, means you might have some better explanation than me, but this understanding you have to need to know. Many times I have seen that we study these assumptions technically, but we never put a thought that why this is important. Means if OLS is take, we are applying OLS, and if OLS taking this assumption, this particular methods, so there must be something important in this. So this is again, now you can see, this is when it's possible. It's only possible when your regression line passing through in some between from the data sets, the raw data. Then only you will have this type of that your residual is the summation of residual is zero and the average of residual is zero. And okay, I hope you got this point. Then fourth assumption. Now again about the residual. Now, Somna, you asked me at the beginning that this residual is important, and now from the all in all the classes you had this that everywhere is this residual term. Okay, now this particular although we have a specific one or two classes specific to these assumptions, these problems, here you will get this in details to understanding behind this, like this homoscedasticity or equal variance, but it's just understand this theoretical meaning is that or we take this, this diagram is much better to than that one. That not only the average of the residual term is zero, but throughout the regression line, its variation is also more or less constant. Now the opposite is, like, this is the assumption we have. Again, these assumptions are crucial to prove some properties. Means that property still we have to do, so that you have to get, then you have more clarity why the assumption is. But just try to understand. Let's suppose we have again this raw data of y and x. Let's again, I'm taking the education number of years and wages. Let's suppose we have some regression line here, some positive relation is there. Now, in the initial means, let's suppose 5, education level 5 means a number of years of education as a 5. 10. It's just I'm taking some few hard numbers, 10, 12, 10 graduation. Now here might be, so maybe you will find that the truth is something different and the assumption is taking something different. Like this assumption is, have this notion is that your residuals means these actual values, and residual is what is actual, and the gap between actual values and estimated regression lines. So these residual terms is not only average is zero, but we are saying its this variation is also constant, means the variation, how much is the variation is in this particular level, is same variation, means constant variation in the second level and constant variation in the third level, all the levels. Now, what will be the opposite is that, like, let's suppose here the variation is this much in the residual terms, and in this particular level, the variation is large. So it might be that at this particular level, the variation is small. This is the opposite of that particular assumption. First, the assumption is that variance is variance of the residual term is constant. It's not this particular case where it's not constant. So first, just think theoretically that these are the cases which we are not taking in the assumption. We are taking that throughout the regression line, the variation means whatever the variation is here, then variation in the another the variation is equal. In term of income, I can say in the consumption behavior, like suppose in the individuals who have a 20,000 income, the variation they have in the consumption expenditure is same or equivalent to the variation those who have 2 lakh income per month. So assumption is about that, but in reality it might not be. And since this particular series, part 3, is about the cross-sectional data, so here you have to think about it very regressively, that is it possible that human behavior, these variables, the nature of these variables, is it possible that if we move from one level to another level, the variation among the individuals will remain same? Like in this particular example, the variation in wages among those who have a five number of years of education on an average is same among the variation in wages those who are graduated or 15 years of education. It's not saying the wages are same. No, that's different. That wages are increasing, that's not a problem here. But the variation is saying that that's same. Means, let's suppose here the variation is of the 10% or 20% from the average wages up and down. That's remain same in among those who have 15 years of education. Now, just put a thought in it that is it possible, means what you think about this, that is it possible that at all the levels this variation will remain same, means, or it will change? This is the another scenario where I have taken this, that those who are graduated, there is a much variation, means as compared to those who are just 10 years of education. So what notion you have to think is that in reality is required is it will remain constant? That's the requirement of the OLS method. And while we do the properties, I'll tell you why that assumption is important. Means there is something, this is a requirement of the model. But just think in the practical phenomena in the human decision making process and the variation we have in the variables. Is it equal variation or unequal?
Sir, sorry to interrupt you. This is what I was talking about. That in general we see, like you said also, that there is a variation, and there has to be a variation because of the different levels. So if we can't also ignore the variation that is there in the process. So that's something which I wanted to know, that if we follow on through the assumptions, then if the variation is there and we can see it that it is there, and still we are moving on ahead with that okay, this part is constant, and then we can move on with the process or with the model. So there I had a doubt. I mean, I know that
No, no, no.
assumptions are
Model
important.
is model is saying if you have this phenomena and that's not fulfilled with the assumption, then you
Hmm.
won't apply that model. Then you have to skip.
Okay, and in this particular scenario, as you are saying that there are the thing which you were telling about residual term, so these are the things which we are not able to see because we don't have the data. So how do we are just trying to minimize that error. So if we are even seeing that thing in front of us, so it is just that we just try to minimize it according to the whatever model or theory that we are applying. That is all that we can do.
In these two are different means this hetero and this homoscedasticity is like that if it's not in your data the that you can't apply the model means it's not
Okay.
that you have to apply the model either you sort out
Mm-hmm.
this problem in your data
Hmm.
or the other thing you don't apply the OLS model.
Okay. So
So that's
this
why this
restricts to the OLS only.
yeah means they all the methods have the assumptions means that's
They're
not that
different assumptions, right?
different assumptions means that you have to
Mm-hmm.
understand which you have. That's why many times it's not possible to apply the
Hmm.
OLS. That's why these topics we study something in detail. That is it
Hmm.
possible that to deal with these heterogeneity among the variables. So
Hmm.
that's generally we study in details. But as
Hmm.
far this residual term is concerned, for residual, as in the beginning I told you, this something when we study theoretical econometrics. This is
Hmm.
everything in the imagination.
Yeah,
Why it's
right.
in the imagination? Because you don't have actual picture, and it's not possible for all to understand this relation. Like you have some functional form, and where you are saying your particular variable depend upon few other variables. So this imagination is why because you're applying this model, but in the econometric model, you also added residual term, and this residual term is about all other variables.
Variables. Hmm.
Now, while you think about these assumptions, you have to make connection among this relationship with all these other variables that where all these because in the econometric models now we have all these variables as well and these fluctuation in the from the regression lines are because of not these variables but because of
There is
these
other
unknown
variables.
variables
Hmm.
means there are some other factors so you
Hmm.
have to think in theoretical terms that what other decisions or other variables which are making changes here in the behavior of y variable, which is not possible to capture through the x variable.
Hmm.
So that's causing the change here. So theoretically, that means that decision and everything is there. It's that it's not in your data set, or you don't have to capture it through your questionnaire or something about that. But theoretically, that decision making in the minds of those variables when calculations are doing that's there in the practical means in the field that changes are there because of the other things that's why I say this theoretical this understanding of the econometrics something in the imagination and better you connect these dots the better you can understand the econometric process and the beginning I told you that this is not the mathematics that
Hmm.
many as you asked that how much mathematics is required it's not a mathematics it's just connecting the dots that how you connect these relations it's just understanding of the regression behavior that where you're trying to find the relationship among the variables but then you also have to understand the behavior of the unknown factors as well
Hmm.
and we given a space in the regression model with the residual so all these changes are because of these factors so if assumption is saying that this not only its average is required to be zero, but with that, it's also required that its variation is constant.
Hmm.
That throughout the regression line, this change. So if you think in your theoretical means in your data or graphical that this is not constant, then the OLS method is that either you have to sort out that problem or means you have to transform your variable. Some change is required means you have to cancel out that irregular behavior or that change some method you have to need or the last option that you don't apply the OLS. So in the cross-sectional data, maximum time we find this problem. So it's not that OLS incorrect or your model is incorrect, but that's the nature of the variable. So that's not in your hand. So in that case, you have to just jump through the OLS, but you don't apply the OLS. And it will remain with other assumptions as well. These assumptions are possible to fulfill with the cross-sectional data sets. Okay, I hope this assumption is clear that what this assumption is. Although we will study it in detail, I have two separate classes on this particular problem. Then, okay, yeah, this one is done. This is an example they have given that it's not equal, it's changing. Then why it will change, what are the causes, what are the consequences, that in detail we will study in next week or in the third week, yeah, second week of November. We study these in detail. Then again, another crucial problem that now again this particular assumption is about the residual only. That given any two x values, the correlation between any two residuals is zero. Now don't go with the equation, but just understand its theoretical meaning, that what it means. Now generally you study this particular problem in the time series data, but this is also in the cross-sectional data sets as well. So graphically I can explain this particular, although in autocorrelation chapter the graphs are not in that particular chapter. Means graphs for me something is the tool to understand the process. Means when we are child, means if you take age group of this 0 to 4 5, then we understand things from the pictures, generally what we see, and we try to copy and that. In econometrics, in the theoretical econometrics, although these books try to give a maximum graphical explanations, but still compared to other textbooks, this Gujarati have maximum graphs. Otherwise, in other textbooks, the graphical explanation is very less. Now, what it means is that if I can take, take this another example. Let's suppose you have a data for now. This is your model. By beta 1 hat plus beta 2 hat x. I'm taking one single independent variable for simplicity. U hat. Okay, so let's suppose you collected this data from 10 different households and take a variable here again, wage, education. Although this problem again autocorrelation, again we have two separate classes on it. But just understand this, but it's in the cross-sectional data. I'm taking example of the cross-sectional only. We collected this data sets from 400 or 500 households and so on. First individual might be earning, I'm taking this three figures in thousands, might be earning 10,000, and his education level is, let's for 6th standard. Then second individual is earning 15,000. Its education level is 8th standard. Third individual earning 20,000. Its education level is, let's take graduation. I am taking education in years, not education level, but education in years. Fourth individual is earning 55,000. His education level is, let's suppose, he's a businessman or something, so is education level is just graduate. Fifth one is earning 30,000. His education level is just take okay. Again, I'm taking graduation. Sixth is earning only 5,000. His income level is just let's take its 10th pass out, and so on. Now, maybe the sixth individual is handicapped. His education more than these two individuals, but income is less. So that's why I'm saying this. In social sciences, the relations are not what we have, and we can't control these all the things, right? All other things. So control experiments are not possible. That's why we give a space to unknown factors. So this assumption is that any of the two x values and corresponding residual terms, their correlation is zero. This is the assumption, no autocorrelation, and I'm saying in the cross-sectional form, not the time series form. Means if you have estimated these values, generally we estimate these values with OLS, right? And if you put these two values, you can estimate the y hat, right? And then if you have a y hat, then y minus y hat is your y hat, right? That is your residual term. So whatever residual term value you have here of these all the individuals, this residual term, this zero correlation means that this correlation is zero. Means they are not related to each other. What it means is that the unknown factors or the other factors of the first household, means this particular individual, the way he is taking the decisions, this education we have kept in the model, the other factors we don't have kept in the model. The other factors, the way he's thinking about the other factors is not related to the other individual, is his other factors or unknown factors. Means the way he's thinking of the decision is taking about all other factors, the impact on the wages is nothing to do with the other individuals, and so on. Is these decisions of other factors about other factors and other decision making process is individual and it is not correlated. I mean, it's individual specific, and you are taking your own decisions not based upon others unknown factors. I hope you got this point, that what it means now. It's requirement, I tell you in the properties why this particular assumption is taken, means why theoretically it's important, but I hope you got this point that and there is no harm, although it is that the decision one family is taking about the unknown factors is not related with the other family. Means the way they are taking decision in their home about other factors. And the other explanation you can give that generally we live in a societies, in villages, and in a groups, in societies. So our decisions are generally related with each other in economic terms. That it's not that we won't copy each other. Means you might say that, means in the theoretical framework. But then my counter argument is that every family's situations is different from the other family. It might be that you are in a particular society, your caste is same, you have a same number of individuals in your family, your children are of the same age group, and you are in the same business company, means you are doing a job. But it's not possible that this unknown factors is not about something specific to any particular common factor. It's about all other scenarios. For example, your relatives are different, your parents are different, your education, the school is different, your peer is different, your boss is different, your saving decision is different, means the way you are spending money is different. The combination of all the unknown factors of your particular individual is not possible to can match with the other individual. If it is means if it is the thing in the data, then you have to go with the reason that why that is in the data set. That if that is something correlated, then you have to inquire about means why it is. Then you have to understand. But from my understanding, what I understood from this assumption in the cross-sectional data, although in the autocorrelation examples in these all the textbooks you find time series data example, not cross-sectional. But since my research area is from the cross-sectional, so I try to understand that how it is in the cross-sectional data. That means, okay, we live in a society, we live in a group, we may be working in the same company, our children are in the same school, means many connections we have, but still unknown factor is a combination of n number of factors, and that combination is not possible that can match with the others. So this assumption is not harmful that we are saying this unknown variables are uncorrelated with each other. Means of the first family with the second with the third. Uh, I hope you got this point. Or any counter argument about this particular assumption. Although in time series it's not possible to defend this assumption, but at least in cross-sectional data, that's why in cross-sectional data this autocorrelation problem is not common like heteroscedasticity problem. This problem you rarely found in a cross-sectional data because this combination of unknown factors is totally different among the individual or households. So, and if your sample, and that's why in the sampling methodology, we suggest that random sampling, that you pick samples from different heterogeneous groups so that you find this maximum variability, and then there are less chances that you will face these problems. Generally, if your sampling is biased, then only you will face this maximum problems. If your sample is designed in a better way, then these problems you will rarely will find. Uh, is it clear this assumption? Or still any doubt? Don't go with the equations that you can practice, but the important thing you can understand here what it meaning. I'll go this equational form as well when we prove the properties, but so far just try to understand in the theoretical form that what it means. I hope is it okay you got this point that why this assumption. Okay, this example is of the although they have taken in the time series graphical. Yeah, this is a graphical picture that unknown residual terms there is no relation in these two A and B. There is a relation, means they are moving in some direction. That's not required. Means the requirement of the assumption is that there is some scattered indecisions, and these are not related with each other. I mean, this is the assumption, but this might be a situation. If this is a situation, then we have to inquire why this situation is. Then sixth assumption, although we did it in the property as well on Thursday, it's okay. Again, the theoretical meaning, just try to understand. Zero covariance between residual and independent variable. Means whatever variable we have, for example, here we have a education in years and then unknown factors. With this pad, my writing is not good, so that you have to forgive me. I hope you're understanding. Now this assumption is meaning is that the dependent variable, then you have independent variable. I'm taking in the sample regression functional form, but although these assumptions you can just try to understand it population regression form. Now here we have taken this as education and y as a wages. Now the residual unknown factor is now Just think as maximum variables on which wages can depend. Maybe your wealth of the family, parental education, not your education only, but the parental education, place, maybe rural or urban, occupation means in which occupation you are you type of occupation, are you a household, sorry, casual labor, self-employed, regular wage, if it's across country, then depends upon a country as well, and so on. Means you can just imagine all other factors. Assumption is that these factors, all the other unknown factors, are not correlated with your dependent variable. Means this correlation is zero. Now just take a break and just think, is it the correct way? Means is it that these variables are not related with your independent variable? Just think about it. What do you think that? Now, I have just taken this hypothetical example. Okay, the situation will be differ. I'm just taking this hypothetical example. Now, if you go individually, you might say there is a relationship between education, my education with my parental education. If my parents are more educated, definitely they prefer for my education. But in that case, you are taking individual unknown variable. Means you might compare one individual with the individual and you find some correlation. But this unknown variable is combination of all. So it's not possible always that this combination of all the factors will be correlated with it. As individual, it might be. That's always possible that some factor that we are not taking in the model is correlated with the independent variable. But this combination is not possible. Means the combination of wealth, parental education, rural urban occupation. Now there are n combinations, right? So that combination is not possible that it's correlated with the X. But if you have a multivariate regression model and if you have a more number of independent variables, then the space from these unknown factors will get reduced and here the variables will increase, then this explanation will change. But so far, this combination is not. How can we correlation be zero? It's not always zero, but nearby zero. Means theoretically, we are saying zero. It's not that actual figure is zero, definitely. But the thing is it significant correlation? In correlation, in cross-sectional data, we never go with the degree generally. They generally go with the significance. Okay, there is a correlation, but is it significant? Here, the case is that even if you have a correlation, that's not a significant correlation. Zero is not possible. If we have a number, zero is not possible at all. But nearby zero. Then, okay, this is a technical number of observations and must be greater than number of parameters to be estimated. This is mathematical requirement that to solve the equations, like we have here two parameters. So at least we need two equations, right? That's that y1, y2, y3. Now this might be a problematic in medical sciences, although I don't know the not only medical sciences, but this yeah psychiatrist and psychology as well. There I have this few experiences from my friends that let's suppose you are taking some outcome in some form of some disease or something, and where your you are taking indicators as your independent variables. Let's suppose you have a 10 or 15. Let's suppose take example of cancer. When some particular patient go visit to a doctor, doctor try to diagnose various indicator, means they ask various type of tests they perform in medical data. What they do a diagnosis. In the diagnosis, they perform a various tests. Let's suppose some particular outcome of disease depends upon various diagnosis, means various type of indicators. But to overall study, you only have 3 or 4 patients. Means you the parameters like here beta 1, then beta 2, then beta 3, beta 4, beta 5, and so on is greater than the number of patients you have. So this is a mathematical that at least to solve these equations, you need at least these much of the equations, the parameters you want to. So that's a mathematical requirement. In social sciences, you have this liberty. In economics and all, you have a large sample size. You can go and just try to collect the sample size. But or maybe like you are doing study on some prisoners and you don't have this access to maximum. So there might be a situation that you have a restriction of sample size and you have many other factors, their coefficients you want to estimate. So there is a restriction. This is a mathematical restriction of the model. Then 8 x values in a given sample must not all be the same. Again, mathematical form that the variables here you have like x1, x2, x3, x4. What it means is that when your y variable means one individual to other individual you are shifting, x values are also changing. It's not that all the values are same, although it's not possible unless you take some category. Like you have taken data only from the Punjab and you have taken this variable that Punjab is equal to 1 and other states 0. You did a survey only within the Punjab. Although you categorize that 0 for the others, but the survey is only from the Punjab, then these codes will get 1 value, right? Because you are saying for Punjab it's 1. So there is no single variation in this x value. So there is nothing this correlation regression can measure about these coefficients. So that's not possible in the OLS estimate. At least some variation is required. So this might be some mistake by error that you didn't realize that you are giving same value for all the variables. Otherwise, not possible. Means there is no variable where all the values will be same. Okay, the model is correctly specified. There is no specification error. What it means is that the specification error is of how the many types, means it's not of one specific type I can describe you. It might be that your scatter diagram is saying that relation is something like that. Okay. Something exponential type of. And you have picked model and the regression line is something like that. So this is again a problem. Means it means that in your model you might need some x square, x cube, some adjustments were required, but you ignored that mathematical thing. Another thing is that in your model there are other important factors that definitely needs to be included, but you ignored those variables. Other type of specification is that you unnecessarily picked more independent variables and they are not required. Means the theoretical meaning is that that particular variable is not explaining any change in the independent variable, but unnecessarily you have included in the variable. So again, that might be a problematic. So I try to take 1 or 2 classes on the specification test and specification errors, but this might be in your functional form. That might be a case. Omission of important variable, that might be a case, or addition of unnecessary variable, that might be a case. So the specification error needs to be correct. Then only your estimates will give you a better picture. Means what will happen? Like this example we are taking, that actual data is something like that, but the equational form you have taken some linear and line is somewhere here. So here it's not possible, like the residuals we are saying average is 0, the constant variation, is all those assumptions will not possible to fulfill. So these are indirectly depends upon the functional form. So correct functional form is required. This is again a crucial assumption. This is again data set is something like the Philip curve. So this is a non-linear. You can see that, but parameters are linear just by changing the functional form of the dependent and independent variable. You can take other non-linear regression models as well. Just requirement is that parameters needs to be linear. And in the end, yes, perfect multicollinearity. This is the again about the independent variables. Again, I'm taking this wage and education model, and I'm taking one more variable. It says I'm taking parental education or father's education. And then residual terms, unknown factors. Now, what will happen? Let's suppose, I think this is hypothetical, okay, that the education, individual education and father education is perfectly correlated, means correlation is 1. Means those who have a high father education, higher education, low father education, low education, means perfect correlation. Although it's not possible, but just take this example. And the problem is that the whole idea of including the other independent variable in the model is that we want to find that with the change in the education in 1 year, how much is the change in the wages? That's the first purpose we have. That's why we include this education variable. Means you might, that's why you might have included this education in your model or whatever variable you have. Second variable you also included in your variable because you want to find that how much is the change in the wages with the change in the father education. So for that the coefficient is beta 3. But if these both are highly correlated, means perfectly correlated, then it's not possible to describe that the change in the wages is because of the education or because of the father's education. Because in the partial slope coefficients, we keep other things constant. But if this other thing is perfectly correlated, technically it's not possible to keep it constant. So then it's not possible to find the effect of education on the wage, and the individual impact of father's education on the wage. Might be we get some number which tell us the combined impact, or technically in the OLS method I can say this is not possible. If it's perfect correlation, will tell us the error. So it's not needed that. And theoretically it doesn't make it sense that if you both the variables are described in perfectly correlated, then you have to keep at least one of them. Why you are keeping both of them in the model? Means if it's not something new that this father's education is defining changes in the wages with the education, the first variable you have in the model, then what is the point to keeping the other variable in the model unless it is something defining uniquely about the changes in the wages? So if it's a perfect correlation case, that's we say multicollinearity. So out of these assumptions, in detail, I take classes about the autocorrelation problem, this last one, multicollinearity problem, heteroscedasticity problem, and if we will left with some time, specification problem in this particular part. These assumptions we will study in detail. So we study means what are the problems, what are the causes, consequences, and is there some remedial measures are possible that we try to do. And others are technical assumptions. So that any questions so far? Although I was thinking about it, do something with the properties as well because next week, Thursday and Friday, I might not be able to class because I have to convert these Woolridge data sets that I got from my students. That data sets are not in a Stata format, so I have to make them in a Stata format so that we can do practical exercises as well. These are the data sets. I don't have so far access to those data sets, only 10 or 15. But Woolridge data sets I have access, but that need a conversion from raw data to this Stata format. Okay, so now from here we started. Okay. Estimate is done. Assumption is done. Assumption we studied because in the OLS methodology, if these assumptions will fulfill, then only there are few properties. So now the important thing is here is properties, that what are these properties, and that's the only criteria here why we prefer OLS or not. So next part is the property and properties, and these properties generally this is Gauss-Markov theorem. They prove these properties with the OLS estimates, but only if assumptions will fulfill. This is same like last time we did these four properties, right? But these are the mathematical properties. This Gauss-Markov theorem is the statistical properties. Similarly, same like these properties, we have three or four properties of statistical properties. Why in quadratic form? If that's your nature of variable, means if you have something convex and concave, means your slope is increasing with decreasing speed, slope is increasing with increasing speed. That's the theoretical thing. That's what I am telling from you the beginning. Your mathematical model functional form depend upon your theory that you have to define with the theory. Means if you are linear, is that slope is constant, and non-linear is that slope is not constant. Now slope, what are the other possibilities? Other possibility is that either the slope is increasing, either the slope is decreasing, or either the slope is changing the form, increasing, decreasing, decreasing, increasing. Now, these are the possible combinations. That combination is from the theory, like the micro example I have given in the production functions, that we study returns to factors, economies of scale, because this economies of scale means throughout the production stages, this returns are not constant. Similarly, in the model, you have to see in the theoretical framework of those variables that why that slope is not constant. No, but age with other, what will be the other variable? It's not the one, what will be the other variable you are looking in this relation? You have to look with other variable, that how this particular variable is linked with the other variable. Means the changes are same, means 1 to 1, or that change is not same. The speed of change is something different. Means that's the speed of change I can say to this slope variable. It might be increasing or decreasing. So that's, and it's not the quadratic equation. There are many other non-linear functional forms that you have to practice. I told you that due to time limitation, I try to take few examples which those particular functional forms you might have studied in theoretical framework. But for that specialization, you have to go with the specialized subjects like microeconometrics, macroeconometrics, then industrial econometrics, time series econometrics means now in the industry, production functions. Production functions are not always a linear case. Then you have to go with that theory, like Cobb-Douglas production function, series function, and then you have to look upon the relations that in theoretical background, why that slope is not constant, and accordingly you need some equation. So with age, if you can tell me other variable, then I can comment this. Okay, age is increasing day by day, second by second. But what will be your other variable? This is a combination of two variables, not a single variable in the quadratic form. It's about the relation in the quadratic form. So now we left with the properties. Today is also, now it's already 2 hours, so I'm tired. Let's take it in the another class. This properties, blue properties. I'd give you both solution for bivariate as well as for matrix. Although I only prefer matrix, just bivariate I am doing. The one reason is that I think in all the state universities they start with the bivariate and they have an exam. So any one of student is watching these videos for the exam purpose, at least he or she has these derivation proofs. Because these notes when they photo straight from senior and juniors, many time I found the mistakes. So I'm taking care of that as minimum as possible. But still, if you any of you find some problem in derivations, let me know that maybe I have in well, I'm writing or might be I'm copying or I'm giving some reference from the book. Some mistake might be there. So then just correct me. But although I'm trying to give you the explanation in as easy form as possible. A gender education. No, no, two variables, Pallavi. It's not this particular regression analysis is something where the graphical form. Age and gender. But gender is your categorical variable. There is no slope in there. There is nothing in the categorical variable. Gender is the categorical, so there is no slope or something, nor is constant, nor it's changing. Not categorical variable. It's about the quantitative. Slope is about the quantitative variables, not about the categorical variables. Okay, so I think it's more than enough for today. I hope you got these assumptions and this link that you start with the theory, then mathematical, then econometric. In the econometric, we need estimates. For estimate, we are taking some method. That method is only useful when we fulfill the assumptions of that particular methods. To understand this, first we have to understand the estimate process, then assumptions, then properties. And in the end, it's not that we can rely on these results because these results estimates are from the OLS is not designed keeping that you're working on sample or population. This is a method. But since we are doing this with the sample, so it's not that we can just try to jump on the conclusion. So in the end, we need hypothesis testing as well for all these estimates. So that we will do after this first part. So first now we are only left with the properties. After properties, in the tabulation form, we will done with coefficients and variance, and then we will jump to this hypothesis testing, T test and F test for overall model and individual coefficients and goodness of fit. These are the parameters whether we can rely on these results or not. So that's we will do after the properties. So tomorrow, if I had time, I'll inform you. Although tomorrow I'm quite busy. Then on Monday, I'll try to complete these properties part so that then we can jump to other important topics, goodness of fit and hypothesis testing. So thank you so much. I hope you find it useful and try to, those who are doing it first time, please try to practice as much as possible. Read about this. Reading, then imagination, make your own graphs. While I am studying these subjects, I make my own graph and I try to study in my own imagination form. Unless I am figure it out, like the examples I am giving you here, means this particular way, unless I am sure about my own explanation, I won't jump to another step. And that explanation you also need, then only you can understand this implication of these methods. So while trying, just try to understand the process as well. References I already shared with you, and these books are standards throughout the countries. It's not about the India, USA, Europe, all the countries. These books are standard textbooks, so that you can see. Okay, thank you so much. So then we will meet on Monday 3 p.m. Thank you so much.